What if an aircraft could cruise at 3 times the speed of sound while carrying a nuclear payload? Specialized brazed steel panels prevented structural friction meltdown. Designed to fly higher and faster than any interceptor on Earth. With thunderous majesty, the Silva Giant took to the skies. 6 massive turbojet engines prepared to unleash raw power. Radical delta wing geometry managed extreme shockwave compression. Internal weapons bays housed massive strategic nuclear payloads. Forward canards provided exceptional pitch control at high speeds. Advanced analog navigation computers mapped global intercontinental trajectories. Variable geometry intake ramps trapped supersonic shockwaves efficiently. Complex flight management systems oversaw multi-crew station metrics. Engineered to cruise effortlessly at 80,000 feet altitude. Real-time telemetry streams monitored fuel distribution across massive tanks. Precision engineering guaranteed structural endurance under thermal stress. Next, we explore the revolutionary compression lift and Mach 3 speed. Outer wingtips folded downward 65 degrees during supersonic flight. Downward wingtips trapped supersonic air to increase directional stability. A mechanical windshield visor protected glass panes at Mach 3 speeds. Friction heating pushed outer skin temperatures past 600 degrees. Compression lift trapped high-pressure shock waves underneath the wing structure.
Punching through the sound barrier with breathtaking aerodynamic grace.
Active fuel shifting balanced center of gravity changes at supersonic speeds. Stability augmentation systems kept the massive airframe smooth and controllable, sustaining high-speed flight across thousands of uninterrupted miles. Special expansion slip joints allowed the steel frame to grow under heat. Coming up next, we explore the high-stakes flight testing and historical legacy. Unmatched high-altitude velocity established a new paradigm in aviation. Ascending into the high stratosphere where air density drops away. What did flight test engineers discover when pushing the Valkyrie to its absolute limits? Flight testing pushed experimental aviation into uncharted territory. Data recorders captured unprecedented velocity and structural telemetry. Advanced avionics packages ensured complete tactical tracking capability.
Chase aircraft monitored shockwave formation during high-speed runs. Low-altitude flybys demonstrated remarkable handling for a heavy bomber.
Post-flight inspections verified skin panel integrity after thermal soaking. Triple redundant hydraulic systems ensured fail-safe flight control. Every morning, test flight expanded the boundaries of high Mach science. Cruising where the sky turns dark and the air turns thin. Thermal telemetry mapped heating patterns across every square foot of metal. Canard actuators adjusted continuously to dampen atmospheric turbulence. Pioneering data gathered during these flights laid the groundwork for future transport. A monumental achievement in high-speed aeronautical engineering. Shaped by bold visionaries who dared to conquer the thermal thicket. Next, we explore the shifting political landscape and the end of the bomber era. Why did the world's most advanced supersonic bomber program ultimately come to a close? Shifting military priorities and intercontinental ballistic missiles changed strategic doctrine. Advancing surface-to-air missile tech reduced high-altitude bomber invulnerability. Transitioning from a weapon system to an invaluable high Mach research platform. Valuable flight test data paved the way for future supersonic transport concepts. Engine innovations tested on the Valkyrie influenced future propulsion design. Every research flight contributed priceless aerodynamic data to science. Material science advancements from the program live on in modern aerospace. Material science advancements from the program live on in modern aerospace. Bridging mid-century experimental flight with 21st century supersonic study. Precision engineering marked the final chapter of the Valkyrie flight program. Her final flight delivered the giant safely into aviation history. Master blueprints remain a testament to bold engineering ambition. The technological milestones achieved continue to inspire aerospace engineering. Next, we explore the eternal legacy of the Mach 3 giant. Extraordinary aviation achievements leave an indelible mark on human progress. Archival flight records preserve the golden age of experimental aviation. High-speed commercial flight concepts draw direct inspiration from its delta shape. The relentless pursuit of speed demands extraordinary engineering courage. Preserved museum artifacts showcase the peak of mid-century manufacturing. Innovative cockpit instrumentation sets standards for decades of flight. Even across changing eras, radical engineering principles remain timeless. Global aerospace design continues to study compression lift physics. An ultimate masterpiece of supersonic scale and structural audacity. Precision engineering ensures absolute legendary status across aviation history. The spirit of high Mach innovation drives the future of flight. Engineered for the impossible, built to master the skies of tomorrow. XB-70 Valkyrie, the ultimate Mach 3 supersonic titan of the skies. The skies are never a final boundary. They are the beginning of supersonic possibilities.